Let's talk about sequences and series. I'm super excited about this one. It's going to be great. I hope that we have the review. Here it is. And we're going to be using a mixture of calculator and spreadsheet. I will begin with calculator, then we'll transition to spreadsheet. So you can do either one. Here we go. Let's write in purple. It's fun. I use this example a lot because it's incredibly practical. Theater has 8 seats in the first row, 11, 14, and so on. There's obviously a pattern here. What I like to do is write down everything that I know and also realize what it's asking. How many seats are in the 20th row? So if I was going to label these, this would be A1, the first term, and then A2. And you don't have to use A, but I often do. It'd be A3. And then the real question is, hey, what's the 20th one? I don't know. Well, it's not 20. Okay, let's just be real honest. It's not 20. But if I kept this pattern going, I would have added 3. Notice the pattern. I'm adding 3 every time. I would have added 3 19 times, not 20 times. So if I go from this term to this term, I added 3 once, then I added 3 again, then again and again. If I did that to get to the 20th term, I would have done that 19 times. So here's my formula. To get to the nth term, I will take the first term and I will add my common difference a certain number of times. And that number of times is always 1 less than the term number that I want. So again, if I wanted the 20th term, then I would have added 3 19 times. So in order to get the 20th term, I need the first term, that would be 8, plus the common difference, which would be 3, and then 19. That'd be 20 minus 1. I should have put 20 minus 1 just in case you're going to look back at these notes later. I was getting ahead of myself when I put 19. I was just having so much fun with this thing. I'm struggling with the whiteout, that's for sure. A big glob of whiteout, nothing to show for it. 20 minus 1, obviously 19, but I just didn't want people to be confused and be like, where'd that come from? What I also like to do, and it's already sort of implied in this problem, is that this is an arithmetic sequence, and it's arithmetic because we are adding 3 every time. So D was 3, and the first term is 8, and the number they were asking for is the 20th term. So there we go. That's it. That's fantastic. We have found everything we needed for the formula. I've already put it in. So I'll just grab a calculator and we'll do this. So we start at 8, and then we will add 3 19 times. And the 20th term, the number of seats in the 20th row, is 65. So the 20th term is 65. Spreadsheet, if you have it typed correctly, will have told you the exact same thing. Let's jump to number 2. If there are 20 rows in the theater, how many total seats are in the theater? Now we get to a different type of question. They're still talking about the 20th row, but now we want to know the total number of seats. And that's a different formula altogether. That is the sum of the first ever how many rows. In this case, it's 20. And the formula looks like this. A1 plus A sub 1 plus A sub n. So these are the number of seats in the first row. These are the number of seats in the nth row, in this case, the 20th row. So if you find the need to write all this down again, you could be like, oh, my common difference is 3, which actually is not necessary at the moment. My first term is 8. I knew that. Same problem, by the way, just different question. Oh, I'm dealing with the 20th row. Oh, here's what else I need. I need to know the nth row. I need to know the 20th row. See, I'm going to need that. And that is something I just found from the previous problem. So whenever you were doing this arithmetically, then you were going to need to know the number of terms in that, the number of the last term. You need to know what that last term is that you're dealing with. So in this case, it's 65 because we already found it out. So we're going to just plug that in. So sometimes when you're doing the arithmetic sum, again, this one is arithmetic. These are the same question, the same information, different question. If you are asked for an arithmetic sum, you're going to have to go through this process in order to be able to plug that number in right there. Okay, so this actually is 2 problems in one. If they would have started with this one, you'd have had to find all that first anyway. So the 20th term is really, well, 20 divided by 2, that must be 10. And then 8 plus 65, actually we can do this one in our head. 8 plus 65, 73. 73 times 10 is 730. There are 730 seats in this theater. And just to put things in context, I'm going to actually write that down. Seats. All right, now things get fun. The ball is dropped from the top of a building onto a sidewalk, and the height of each bounce is measured. And it's a good little physics problem. The ball reaches a height of 40 feet after the first bounce. So it bounces and reaches 40. And then it reaches 30. And then it's 22 and a half. And then blah, 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 blah. And I want to know what happens on the 8th bounce. So same idea, different problem. A1, A2, A3, A8. And that's what I want to know. I need to know what the 8th term is, and I don't know what it is. Well, let's find the pattern. And I like to go, this is an awkward phrase, but I like to go pattern sniffing. Just sniff out the pattern. I'm not going to smell the paper. That would just be awkward. But anyway, to turn a 40 into a 30, I'd subtract 10. That's fantastic, but that will not get me to the next term. So it is not arithmetic. I'm not adding the same thing or subtracting. I'm not adding the same negative number every time. So in this context, it's either one or the other. So I will say that this one's geometric. And if you don't know which one it is, you can kind of test it. So let's test it and see what happens. 40 times something gives me 30, and it's not obvious. So what I like to do is the second term divided by the first term, second term divided by the first term, and I get that. So what that really tells me is I am potentially multiplying by 0.75 every time. Because I am multiplying, it is a common ratio, not a common difference, so 0.75. Now, I'm going to verify that just with the numbers that I have. So 40 times 0.75, that does give me the second term. 30 times 0.75, that does give me the third term. Lucky me. And I could keep going if I wanted to. Yay, there's the fourth term. 5, 6, 7, 8. That's actually my answer right there. But let's get it a different way. Okay, I mean, you know the answer now, and you're like, hey, let's move on. But let's get the formula. First term is 40, and they're asking for the 8th term, the 8th bounce, how high the ball reaches after the 8th bounce. So here is my formula. We'll write this one in blue, just like I did on that last one. That's just a squiggle to separate my work, just so you know. My nth term in a geometric sequence is like this. I need my first term for sure. And then I multiply by the same thing every time. I multiply by whatever my common ratio is. But that common ratio, like if I wanted to get to the third term, for example, I would have to multiply 1, 2 times, okay? If I wanted the 8th term, I'd have to multiply 1, 2, 3, 4, 5, 6, 7 times. So whatever term number I want, it's that minus 1 that I would multiply by that many times. That's why we have exponents. So here we go. We have a formula, and we will type it in. So the 8th term is 40 times 0.75 to the 8 minus 1, and I will type that in. And here's the answer again. But just in case you miscounted or something, you could do it this way. By the way, in case you care, when I actually went through that whole process and I did all this, that's called recursive. I was recursively going step by step. What I'm doing now is it's called explicit, and explicit has multiple meanings. Explicit in the most common sense, the most well-known sense means vulgar. I like to refer to it as direct. Okay, so like if something is vulgar, it is very direct and says stuff that probably shouldn't be said. However, this is an explicit formula in that it directly takes me to the answer. Notice this directly took me to the answer, whereas in the other one, I had to slowly get there step by step. Okay, so an explicit formula will take you directly there. So I like 2 decimal places. It's just how I roll. Actually, I like 3 decimal places in other classes, but for now, we'll just stick with 2. Okay. All right. And now we go pattern sniffing, and we are going to start using the spreadsheet in just a moment if you have the spreadsheet. If you don't have the spreadsheet, you've missed a great opportunity to learn some fantastic stuff that is very practical, but whatever. Anyway, what is the 19th term? Well, let's just start writing, you know. Is it arithmetic? Is it geometric? I don't know, but I do know they're asking for the 19th term of this sequence. Well, I know the first term. Man, this is easy. Well, 5 turns into a 9, and a 9 turns into a 13. Okay, let's see. 5 plus 4. Okay, 9 plus 4. Ah, yeah, we're adding, which is a difference, not a ratio. So arithmetic and d equals 4. So here's what I'm about to do. I'm going to go to my spreadsheet. I'm just going to type it in. I would love to use this formula, but I'm not. See, that's why we have spreadsheets. We have the technology so we can make things easier. Actually, sometimes making, let me go to the spreadsheet while I talk and ramble. Sometimes making the actual spreadsheet is the hard part. And then once you get the hard part behind you, then you have the easy part. So the hard part was actually knowing what to type where. And now that the whole thing is typed and it's ready to go, we'll just put things in the right place and we're good to go. So let's see, A1 was 5 and D was 4 and N was 19. And I have a couple options here based on the spreadsheet I have. This is actually telling me the nth term would be 77, or the sum of the first n terms, or 19 terms, would be 779. Make sure you know what the problem is asking so you're picking the correct thing. And it is arithmetic, so we're over here, and it is the nth term. What is the 19th term? So it'd be 77. So let's go back to the paper, and we're going to write that down. The 19th term, the nth term, is 77. All right, same question, different numbers. What is the 12th term? Okay, well, 12. My first number is 200. And all right, I'm adding 150. I'm adding 150. Nah, I'm not adding 150. This one must be the other option. And in this class, there are only 2 options. There are actually infinitely many ways of doing this. It's not only arithmetic and geometric, but for now, that's what it is. If you have no idea what your common ratio is, do not panic. Let's do it. Let's figure this out. 350 divided by 200 will tell me what my common ratio is. And I have 1.75. Let's make sure, though. I'd hate to get this wrong. So 200 times 1.75, and it gives me 350 times 1.75. Now, if I don't get this number that I'm pointing out with my thumb, if I don't get that, then something's wrong. I did get it. We're good. Yes. Okay. So my common ratio is 1.75. It does work. So now I'll go to the geometric side and go from there. So let's do this. I'm on the geometric side. I have a 200. I have, you know how to type this in. This is the boring part where you're just watching the guy type. And you watch me talk with my t-shirt on my headphones, looking like a telemarketer. Okay, I need to know the 12th term. I've got all kinds of crazy decimals going on here, and that is okay. Let's round to 2 decimal places. So I'm looking at the nth term. So 94286.29. I'll write that down. So the 12th term is 94,286.29. Okay. Now, at this point, you got this. You're like, oh my goodness, I can do this very quickly. Yes, go, have fun. Excuse me. I don't know why I felt the need to cough right in your ear. Hold on. There, much better. However, make sure you are sniffing out the patterns well and you are answering the actual question. So let's keep reading. Let's move on. Find the sum. Ooh, that's important. Of the first 20 terms. This one is, let's see, 1.4, 1.6, 1.8. Let's read it differently. 14, 16, 18, 20. You're going up by 2 every time, but let's be real honest. You're not going up by 2. You're going up by 0.2. If you put the decimals back in there. My first term is 1.4, and I've been asked to find not the 20th term, but the sum of the first 20 terms. This is not tell me the 20th term. This is the sum of 20 terms, and we'll go from there. So let's do it. Go into my spreadsheet. It is arithmetic, and we're going to type 1.4. Again, this is the boring part where you're watching me type. Which number do we pick? Do we pick the 5.2 or the 66? Or do we pick something random over here that's not correct? Let's pick the 66. It's the sum. So 66. If you were to list this out and put all 20 numbers in that order, in that row, then add them together, you'd get 66. Okay. Next 3 problems. We'll knock your socks off if you're wearing socks. Sum of the first 36 terms. Woo! Okay, well, let's just go ahead and go for the obvious. N is 36. 1 plus -1 plus -3. Okay, all right. How do I turn a 1 into a -1? I always try addition and subtraction first. So 1 minus 2 gives me -1. Minus 2 gives me -3. Oh, I'm subtracting 2 every time. So I'm adding a -2. And my first term is 1. So we are dealing with an arithmetic sequence, and it said sum. All right. So don't be like, oh, I got to find the 36th term. No, you don't. If you're doing it by hand, actually, you do. It's part of the formula. But I'm just going to find the sum of the first 36 terms. Let's do this one as quickly as we possibly can. 1, -2, 36, -69. That's it. -69. All right, moving on. A new business open. Oh, word problems. Yes. Love a good word problem. This is where this stuff gets really practical. New business opened with 80 customers on the first day. Some people call them word problems. Some people call them real life applications. Let's do this real life application. 80 customers on the first day. Each day there were 12% more customers. What is the total number of customers that the business had by the end of the 7th day? I'm just going to start writing junk, just stuff. So, A1 is 80, N is 7. It's a common ratio because it's geometric. And here's how I know. When I'm dealing with percents and I'm getting 12% more every day, I'm not adding 12 or adding the same number. I am increasing by a percent. There's multiplication involved. So if you really want to know what it is, it's really, I have 80 customers, plus I also have 12% of 80. So 0.12 times 80. So the next day I had this many customers. Now, for accuracy, I will use decimals, but you cannot have 0.6 of a customer. How many customers do we have today? 89.6. So the next one is 89.6 plus 12% of 89.6. And so the next day they had 100.352 customers. Of course, we are not rounding. And in the real world, with number of customers, we would not have decimals, but we're going to go with it for the sake of the pattern. So here's the deal. Here's what really happened. Multiple ways to explain this, but 1.12. And so here's the best way I know to explain it. You've seen this before. I'm gonna keep 100% of my customers, but I'm also going to gain 12 more. So every time I move from one day to the next, I have 112% of my customer base. All right, and notice that it said more customers, which is why I added. If this was decreasing in customers, well, then you'd run out of business, but whatever. If it was decreasing customers, if it was less, you'd subtract. All right, but let's turn this into the decimal that it is, 1.12, which we also got from here. All right, now notice what it's asking. What is the total number of customers? That is asking for the sum of the first 7 terms. So 80 plus 89.6 plus 100.352 plus the next one plus the next one. We'll carry all our decimals with us and we'll round it at the end. So since we are dealing with customers on the most practical sense, we will not use decimals in our final answer. All right, we did in the setup. This one is geometric, so we're over here. Had 80 customers. We are dealing with 1.12, so 12% increase, and 7. We have had 807 customers. Notice where I'm looking. I'm looking right here. There it is. All right, let's do the next one, and then things change a little bit. It's going to be fun. You earn $60,000 first year on your job, 3% raise each year. How much money total will you have earned by the end of your 3rd year? So total money. So this is a sum. Let's just go ahead and write down what they're asking. There you go. S3, sum of the first 3 terms. So N is 3. My first term is 60,000. And this one is also geometric. And then I have a 3% raise each year. So you don't have to write this every time, but I like it. So 100%. I don't know what that was. That's supposed to be a percent sign. 100% plus 3% is going to give me 103%. If you're like, oh my gosh, I can do that in my head, then, well, do it in your head. 1.03. Okay. I'm not listing my numbers this time. I just don't feel like it. So 103%. So 1.03. So let's just type it. I am about to get $60,000. Yay. And a new car. 1.03 and only 3 years. And so at the end of the 3rd year, I have earned this much money right here. $185,454. However, notice, look at here. In my third year, I have $63,654. So there we go. 185,454. All right, now we get to some crazy stuff, fun stuff, convergence and divergence. All right, so this is this crazy idea where, and I'm going to abandon the spreadsheet for now. This is this idea where if I was to have an infinite series, like I go all the way to infinity, would this number go out of control as I add them? Like if I added 1 plus 2 plus 3 plus 4 plus 5 plus 6, that just gets bigger and bigger and bigger. Or is it going to get tame and get smaller and get towards a specific value? Like, this is a common example, 1/2 plus 1/4 plus 1/8 plus, that's actually the one we're about to do. So this is not a hard and fast rule. There are branches of mathematics devoted to this. But for this idea, if the numbers are getting closer to 0, then this will converge. If the numbers are getting further from 0, then the sum will diverge. Okay, so con means come together. If we have a conversation, we are coming together. If I am talking to you and then I'm like, oh, I digress, I went away from the topic. So die, the prefix die, means to go away from. Con means come together. So does this go away from or come to a specific value? And when I say go away from, is this thing going to just tend towards infinity? So if I had 1/2 plus the 4th plus an 8, actually this one is going to converge. It converges because these numbers are getting closer to 0. And there's another way of looking at it too. And here it goes. I just feel the need to write this. This is geometric, by the way. My first term is a half. My common ratio is, well, if you don't know what it is, that's fine, but we'll deal with it. So 1/2 times something gives me 1/4. Actually, 1/2 times 1/2 gives me 1/4. Times 1/2 gives me 1/8. Times 1/2. So R is a half. And so because this number is between 0 and 1, let's be more specific, because this number is between -1 and 1, this series is going to converge because it's geometric. Again, there are, get where you can see me in the face, there are entire branches of mathematics that are devoted to this, like a lot of, here, let me give myself a big head and drag myself up here. There is a huge portion of what's commonly used as Calculus 2 that's devoted to convergence and divergence of series. It is some of the most fun stuff you'll ever see in your life. But for now, for geometric, just the big idea is this. If your common ratio is a number between -1 and 1, then your series is going to converge. So let's keep moving. I don't know why. I just wanted to look you in the eye and tell you that. Give myself a big head and do that. The formula for this is, notice I didn't put a number here because it's an infinite sum. Notice I didn't be like n equals infinity, okay? So it doesn't equal infinity. Infinity is not a number, it's a concept. But basically I'm going towards infinity. And so here's my formula. And just for the sake of the calculator, I'm going to put parentheses there. So 1/2 divided by 1 minus 1/2. We'll put that in there in the parentheses. And if you were to type that in parentheses, you'd actually get 1. There you go. And we could do this one with a piece of paper. Let me demonstrate, not with a piece of paper. But if I had half a piece of paper and a fourth of a piece of paper and an eighth of a piece of paper and a 16th and lay them all down, you'd have one piece of paper. Fun stuff. Okay, does this converge or diverge? And I have to ask myself, are these numbers getting closer to 0? And the actual answer is, well, I don't know. All right, let's ignore the signs for a second. Let's ignore this positive, negative stuff. 100, 50, 25, 12.5. They're getting closer to 0. They are alternating, but they're still getting closer to 0. If you want to think about it this way, 100's up here. -50 is below here, but it's still closer to 0. 25 is above here, but it's still closer to 0. -12.5 is below, but and so they're going to keep getting narrower and narrower. They're going to get closer and closer to 0 the further you go. Sort of, zoom, zoom. It's that kind of idea. All right. It's called a zoom, zoom. Kidding. It's actually called an asymptote, but you knew that. All right. This one's geometric also, or we wouldn't be doing this problem. A 1 is 100, and my common ratio is, well, interesting. We are alternating signs, so my common ratio is negative. And let's see, half of 100 is 50, so my common ratio is a half, negative 1/2, actually. And so we will figure out the sum using this formula that I like to write over and over. So 100 divided by 1 minus negative 1/2, almost made a sign error there, minus negative 1/2, that's plus positive 1/2. And that gives me 100 divided by 3/2, that would be 100 divided by 2/3. So 200 over 3 is my answer. You can leave it like that. That actually is also 60, it rounds to about 67. 100 divided by 1 minus negative 1/2, you're going to get 66.6 repeating. There we go. So I'm going to stick with 200 over 3. Let's do a couple more. Does this series, do these numbers approach 0? No, they do not. By the way, that one converged. But these numbers are getting bigger. And so here's why. You could be like, oh, A1 is 3 and R is 2. We're doubling every time. Because 2 is greater than 1, because we're dealing with a common ratio that is making the numbers get bigger. They're going to get further from 0. So this one's going to diverge. All right, last one. Are these numbers getting bigger or smaller? It's kind of hard to tell, actually. That's really hard to tell because they're fractions. But let's think about it. That's actually smaller than 1. 3 over 10 is smaller than 1. That is bigger than 1, and that's even bigger. Let's divide these in our head. 5 goes into 54 10 times, 10 and some change. This is 1 and some change. This is less than 1. So these are going to converge. Given the context of what we're doing, we know it'll converge. It's geometric, trust me. So geometric. My first term is 54 over 5. And my common ratio is not obvious at all. I'm gonna go real crazy on you, and we're gonna find that common ratio. Let me get this paper out of the way. Got my Euler and Hamiltonian paths and circuits in the way. And now y'all can see how scratched this table is. So I'm going to put an X on it. But anyway, my common ratio is my second term divided by my first term. And so when I'm dividing fractions, I'll keep that one, multiply, do that. There we go. Cancel your 5s. 9 goes into itself once. 9 goes into 54 6 times. 1/6. My common ratio is 1/6. That's not obvious at all. There we go. We're multiplying by 1/6 every time. And so therefore, because this is a number between -1 and +1, this geometric series will converge, and I will have 54 over 5 over 1 minus 1/6. And I'm about to get something wild and crazy here. I'm trying to do this in my head. Something over 25. Whatever, 54. Hold up. I think it's 270 over 25, and that reduces. I don't know why I'm trying to do this in my head. I'm just having so much fun, I can't stand it. 1 minus 1/6. There we go. It didn't reduce, and my numerator was wrong. All right, 324 over 25. I was trying to do way too much in my head. Way to go. Messed them up. But that's the final answer on that one. Man, that was fun.